Alright, and welcome to a lecture on debugging. So debugging it's kind of a funny etymology, but the idea came from early on in one of the computers that were built. There was something stopping a wire running, and you can imagine this computer that was the size of a football field and connected by very old school wires, nothing like what we're running today. And it stopped working, and actually very famously Grace Hopper found out that there was a literal bug somewhere on a wire causing a short. And so this term came out, debugging, the idea of finding the actual bugs in the system. Thankfully now we don't have insects crawling around our microprocessors, primarily because they would melt, but we still have bugs that show up in our code. It's still a very common thing, and it's something that beginners oftentimes struggle with because it's very cryptic, the kind of things that you have to wade through to first start to understand better how to fix the errors in your code. So one thing to do is just right up front, you should know that developers spend way more time debugging code than writing it. And that's why I tell everyone, actually, don't spend too much time, or don't spend any time trying to make your code clever. Right? Because if your code's clever, then it's going to be hard to read and hard to debug, because you're going to spend much more time debugging it than you ever are going to spend writing it. So here we want to just go over some really quick debugging techniques that help you write better code more quickly throughout the workshops. And we'll sprinkle in little bits of debugging here and there, but this should get you started on some quick and easy tactics. So the first thing, let's start by considering some bugs that come from writing JavaScript code, right? So the testim page in your browser, it passes helpful message to you if it can't run the code that you wrote, right? So as you're working through testim, as you're working through the specs, well, you'll see that in testim in the browser, it will show you errors as they come, right? So for example, this reference error here, sum is not defined, it means that the code tried to find a reference to something, in this example, sum, and that was never defined. So sum is not defined, it's a reference error. And what's cool is that it even tells you the line that it had that problem on, right? And so it says, okay, it was at only odds, which is typically a function. And it says on onlyodds.js, line 11, column 7. Now, I don't know how many of you are familiar with, but this image had a very stark contrast, or very stark appeal to me. There was a book called The Omnivore's Dilemma by Michael Pollan. And what was appealing to me was that he talked about cows and how cows can see a field of grass and know all the little special details about the grass on there, whereas to us it would look like just a field of grass. Now, this is not to paint the image of programmers as cows, but as you look at these things over here, which are referred to typically as stack traces, eventually you'll start to see what's the important thing that I need to look at and what's the important thing that is the rest of the system, the rest of the errors in the system. And over time, you'll kind of be able to zero in on exactly what the problem is. So at the beginning, oftentimes I find people get really intimidated by these, right? Because it's like 50 lines of very cryptic information and you have no idea how to really think about it. So the way I think about this is that look initially for files that you're working on, right? So here I see at attempt sync, cdnjs cloudflare.com. I didn't write anything on cloudflare.com. I don't know what they're talking about. So I'm going to ignore this line for now. And I say, well, object.it, that doesn't sound familiar. Oh wait, this is in a file called only-odds.spec.js. Now, I'm reading stuff out of spec.js, but I'm not writing anything in spec.js. Typically, we're not going to put errors into the test file itself. It could be there. Don't get me wrong, it definitely could be there. And then here's a file, onlyodds.js. Okay, that's the file I'm working on. The other key thing is that on this line, we see line 11. Now this number is very important because it tells us exactly where to go in our file to find the problem. So note the stack trace below the number. The first @ line gives you where the error occurred, right? This error happened on line 11. This line numbers, you have to be careful. They're not always accurate because oftentimes it can be the error happened a little bit above that, below that, and this is where the error manifests itself. But again, it's still a good place to start looking at, is the issue, where the issue is starting from. And one thing I like to do is just Google unfamiliar errors, right? So as soon as you see that reference error, if you don't have an idea what a reference error is, I like to just even copy that line. So I'll copy reference error, sum is not defined, and I'll paste into Google, and you'll get something that looks like this. Right? Reference error x is not defined. And here this is telling you exactly what the error type was, what went wrong. And I would see, this is a good thing to read and just say, try to understand what it's trying to say, right? There's a non-existent variable reference somewhere, and reference means that you try to use it. This variable needs to be declared, or you need to make sure that it's available in your current script or scope, right? So it's a good thing just to check this and immediately see what the problem is. All right, so here, Google unfamiliar errors. In fact, I like just copying the error and pasting it right to Google and just seeing what comes out. All right, now the other thing is that when your tests are failing, you should take time to read what the test is, because oftentimes you're working on something and you're not necessarily getting what the test is asking for you. So don't worry about this. This is a skill that you'll develop as you work through not only bootcamp prep, but most programming learning tools now have a great set of tests that they want you to pass, and then the code that you're trying to write. Because what tests make really nice is that you know if your code is working or not, right? Whereas if someone's not giving you tests, then you're kind of writing code without understanding, am I heading towards the target I want to head towards? So when your test is failing, you'll get an output here that compares the value that your function returned against the expected value, right? So what this is saying is that I expected what you gave me, which is 55, to equal 25, what the test said, right? And so if you read up here, it says only odds returns the sum of all odd numbers between the provided argument and 0, right? So your function gave me back 55, I expected 25. So yeah, this plain English explanation of what the test is for, someone wrote that out to help you know what to do in the code, right? So here you can say it returns the sum, so make sure that I'm adding things up and maybe not multiplying them, maybe not adding them more than once, of all the odd numbers between the provided argument. So then I can go back to the test and say, well, what was my argument and what answer should I expect, right? And so oftentimes you just want to make sure that you are thinking the right way, right? You're thinking that, hey, I'm adding up the odd numbers, because the test might say expect 55, expect only odds of 10 to equal 25. That's not necessarily what's going on. The English explanation is where you should get that information from. So it also helps to look directly at the code that defines how the test is supposed to work. So that plain language explanation here, that was in the only odds returns the sum of all odd numbers, that should also be reflected in the spec file or in the test file, right? So here we see it returns the sum of all odd nums between the provided argument and 0. So that's where testem is getting that text from, right? Testem is not smart enough to see the test and try to infer some kind of meaning. We actually hard code what the test is doing. So look for the string, returns the sum of all odd nums between the provided argument and 0. And we say let return value equals only odds of 10. And we expect the return value to equal 25, right? So what happened here is that this return value, calling your function only odds, got 55. And then the test failed because it says, well, the test is saying, I expect 55 to equal 25. Oh, that's not right. Let me throw an error to the user. So you can see the test here is passing 10, so that helps you debug, right? Then you can say, well, what are the odd numbers between 0 and 10? Right, and you can just add them up on a calculator, 1 plus 3 plus 5 plus 7 plus 10. So all of the code that's inside of the test, besides the line that starts with expect, is just plain JavaScript, right? This is all JavaScript. So the test, there's not anything fancy going on. It's not a different language. It's not using something special in JavaScript. It's just JavaScript. It's just code that's running and then testing your code. Right? And so oftentimes people think tests are something else, something different, but no, they're just JavaScript code that runs your code and then sets expectations around how your code should run. Now I want to talk about something called the debugger. The debugger is my favorite part of coding in JavaScript, because JavaScript's debugger is really, really good. And it's better than anything else like Python, Ruby. Some other ones, I would say that there are some good ones out there, but among the interpreted languages, JavaScript's debugger is one of the best. And I think we can thank Mozilla and then Chrome, because they built really good debuggers into their browsers or into their runtimes. So to use a debugger, all we have to do is anywhere in our code, we just put the debugger keyword. We put that as into any place in VS Code that we want to test, and then we invoke the function that calls it, So you see here on line 5, we put the debugger keyword instead of our only odds function, and then we call only odds. And then what happens here is that if we run this inside VS Code, it will stop the whole world on line 5 and then let you do what you want to do. So it kind of reminds me of the Matrix, when Neo stops time and is able to like move bullets around. That's kind of the power that debugger gives to a programmer, to stop the entire execution of the program and just let you say, well, what is num? What is sum here? What is I here? And you can kind of run one line at a time and see if your program is doing what you expect. And the reason this is so powerful for beginners is because programming to me is mapping your mental model to code that you want the computer to do and understanding, the computer's model of how code runs, right? And so the larger the gap between your mental model and what's actually happening in code, the slower you will be at learning programming. So what debugger does is quickly reinforces that cycle between you having an idea for how something works, asking the computer, is this how you work? And then getting the answer back and saying yes or no, right? So really, figure out how to get into the debugger early on. It's a little bit intimidating because debugger it's kind of like flying an airplane, and I'll show you in a second. It's like flying an airplane, and you're going to feel like there's a lot of knobs for me to adjust here. But it's one of the power tools that will most accelerate your learning. So it's highly worth investing early on in learning. So then in VS Code, you can press that little kill bug button. So it's debug. I guess that makes sense, right? Because you're getting rid of bugs. And then you follow that this little green arrow at the top left that you press, and that will run code line by line. And then you can press the stop button to stop. So there's a panel that will show you the variables, and it continuously updates as code is running. And again, this is really helpful to debug, especially control flow bugs, right? Like loops, if statements, because you think the loop should stop, but all of a sudden you realize that your I is not decrementing or it's skipping over the condition test. Something is happening. If your code's not working, it's very unlikely. Every once in a blue moon I see this where a student's getting a bug and they're like, my code is working, I'm pretty sure I have the right idea what's going on, and we dig into it, and it actually is that their code is working and the library is incorrect. But that's like once in a blue moon. Most of the time, it's something that you're making a gap in your understanding of what's supposed to be happening, and the debugger can help you solve it. And debugger has many features. We'll explore more later. So let me just go into a quick example on debugger. So I'm in VS Code here. I will implement the only sums function. So only sums, we'll have a function only odd. We'll take a num. And we're just going to put let sum equal to 0, and then for I'll let the index equal to num, index greater than or equal to 1, index minus minus, and then I have to, of course, see if it's odd, right? So if this index modulo 2 is equal to 1, that tells us it's odd, right? Any number divided by 2 with a 1 remainder is odd. Then I'll sum plus equal to I, and then at the end I'll return sum. And then we put a debugger here on line 4. So then I will go and debug it. So I'll run here. Oh, of course so I run here, and I'll select the Node.js environment. Okay, so the debugger attached, didn't do anything, it stopped. And you know why? Because I never called only odds to actually get into the debugger, right? So it's a little bit confusing what this piece of code is actually doing. All it's doing now is defining a function and then ending. So of course, the debugger never happens because we never run the function. So here we'll call only odds, and we'll call it on 10 and see what's going on. I save it, debug, run a node. And now you see here, this yellow line is VS Code saying that I've stopped time for you, and now you can kind of do as you will with the code. So here, the debugger's attached. I can say, well, you can even just mouse over things and say, well, what is this? So num is 10, sum, undefined, right? Because that line of code hasn't run. Here I can see variables. So I have this, I have num is 10, and I have sum undefined, right? So let me go over here, and this says run one line. So now it says, it ran the debugger line. Now it says sum equal to 0. So I'm going to run this line. And you see how that immediately changed here. My local variables, now I have 10 for num, and I have 0 for sum, because now it's run. So now, as I run this for loop, first it's running let I equal to num. So now I have I as well inside of this scope. And you'll notice something interesting here. I don't know if this was apparent. Let me close this. That I'm seeing two sets of variables. One is a block and one is local. So local is all the functions, all the variables inside this function, and block now is all the variables inside of this loop, right? Because in the modern versions of JavaScript, for loop blocks also can get their own scope. So here, so first I let I equal num, so now I is 10. And then let's run the next one, which will set I greater than or equal to 1. That, of course, is true. So it's going to run the code, right? It says if I mod 2, and then that is not true, right? For 10, 10 is even. So you see it jumps back up to the for loop. And then I say, OK, I is greater than or equal to 1. That's true. If I mod 2, and now you see I is 9 here. If I mod 2 equal to 1, this will be true. Sum plus equal to I. So you see how now sum is 9. And we jump back to the beginning of the for loop. Then I can say something like here, run until here. I run until this line. Let me see. Sometimes it's, or what? I can just play, and that will run until the end of the function. And you can see here, you won't see anything happening because I'm not outputting anything. But if I console log out this only odds, now we run this again. If I play, it will run to the end, 25, and then close the environment. So it lets you run the program and to completion, but just let you stop in the middle and read what's going on. So again, I really think this is your power tool throughout the course, and you should really take advantage of the debugger. Try to get it working. There's a great course that Google has out on using the Chrome debugger. If you're interested in how the debugger works, I highly recommend taking a look at that course as well. All right, so to recap, in this lecture we talked about looking at the stack trace and really not being intimidated by it, and B, looking for the lines that pertain to code that you've written, and then trying to find the line number. That's the first number on that in that line of the stack trace. And then Googling error messages, right? Just trying to understand what different things mean, like reference error, type error. Those are things that kind of sound arcane at first, but as you get into JavaScript programming, you'll discover more comfort with what those things are meaning, and immediately evoke, okay, I need to look at something. I didn't find this method here. I didn't find this variable, and it's a pretty easy fix. When you're debugging a failing test, is a very few things to check. One is just understanding where it's failing. Two is understanding, reading the test itself carefully and making sure that you're doing what it's expecting. And then three is just reading the test itself, right? Because the test itself is just JavaScript code. What is the JavaScript code doing? And then what is that code expecting to output, right? So if you see the output, you can see, well, why am I not getting the output? And then the final power tool is using the debugger. Highly recommend, get comfortable with it. It's a great power tool. As you just saw here, you can really stop time and just see what's going on in your code and help you build your own mental model of what's happening. All right, see you next lecture.